Today we move from graphing quadratics to solving quadratic equations by graphing, except the method of graphing we're pretty much going to use to do this is a lot of calculator stuff. Let's talk a little bit about solving a quadratic in general. So we know that a quadratic has an equation of y equals ax squared plus bx plus c. And if we want to solve that equation, we typically set y equal to 0. It's kind of like finding an x-intercept. In fact, it is like finding an x-intercept. And when we set the y equal to 0, what we're actually finding is our x-intercept point. So you'll see in this graph right here, I've already solved this quadratic. I know this quadratic has solutions of -1 and 3. Now, solutions to quadratics are called a bunch of different things. They'll call them x-intercepts, they'll call them solutions, sometimes they'll call them zeros, and sometimes they'll call them roots. So if you hear any of those words, they basically want you to solve the quadratic, set y equal to 0, and go. Now, we know that a parabola can look a lot of different ways. It could have two roots, meaning it crosses the axis twice. It could go upside down as well and do that. One root hits the axis once. Again, it can go upside down and do that. Or it doesn't hit at all and there's no roots, so it could miss the axis completely and it could go upside down and do that as well. So if we want to find these roots graphically, we're not going to waste time and go -b over 2a, because honestly, that's not going to find us anything except the vertex. And then to find those roots, we'd have to set this equal to 0 and solve anyways. So we're going to do all this on our calculator today. So let's turn those on. And we're going to go to y equals, plug in negative. Now when I use fractions, I want to put the whole fraction in a parentheses. So 1/2 x squared plus 3x plus 6. Let's just go ahead and graph that in our standard window. So I'll go zoom 6 and have it graph. And there we go. I've got this calculator. Now the problem is I want to calculate these points right here. So I find the easiest way to do this is if I know that my parabola is hitting that x-axis, the y value is 0. I like doing this. I like graphing a second equation of y equals 0 and then finding an intersection. So I go y equals 0, I go ahead and graph it again, and then it graphs that second line even though you can't see it. Go second calculate, I'm going to hit intersect, number 5, and then what I need to do is I need to get my intersection point, or that blinky guy, close to where it's going to intersect. This is a good spot, so I'll hit enter 3 times. And I have one answer of about -1.58. And then I'll get that calculator back up again. And then I'll go second calculate again. Hit intersect one more time. This time I'm going to get the blinker over towards this other intersection. And I've got to get it closer to that side than the other side, or it's going to find the other intersection once again. So now it's closer. Hit enter 3 times. And I have 7.58. And those are my two intersection points, or an approximation of the roots of that graph. So we'll also get a lot of word problems with this, and we've done something like this before yesterday where the kid shot the arrow up. Well, this time we're throwing a baseball up in the air. The height is described by this equation. H of t is equal to v naught, or v sub o, t minus 16t squared. H of t in this case is the height. V sub o, or v naught, is the initial velocity. And it says she throws a baseball up with the initial velocity of 60 feet per second, and we want to know how long will it take to hit the ground. So hitting the ground, if this is the ground and she throws it up and it hits the ground, and we're ignoring her height as the problem says, the ground is at what height? H equals 0. So I want to set 0 equal to the initial velocity of 60 t minus 16t squared. I'm going to go ahead and graph that. Again, get that calculator out, type in y equals 60 x minus 16 x squared. Get rid of all that other stuff from the last problem. I'm going to keep my 0 there because we're going to want to find the intersection. If I want to see this whole thing, I better adjust my window. I know that at 1 second I'm going to be 60 minus 16 high, which is about 44. So I'm just going to go up to, let's say, 80 for the heck of it. So I'll go down to y max, set that equal to 80, go ahead and graph. And there's my parabola. I wanted to find how long it's going to take to hit the ground. So there it is hitting the ground right here. So I'm going to go second calculate, intersect once again, 5, move over to that lower spot on the ground. And it's going to find that intersection for me after hitting enter 3 times. It's after about 3.75 seconds. So here's another one where we've got to solve it. However, in this case, this quadratic is not set to 0. We need to do that. Always, if you're trying to solve a quadratic, set aside equal to 0. Like so. We go back to our calculator, plug this in. So I've got x squared plus 5x minus 7 we'll do that in the standard window. Take a stab. I don't really see the whole thing, but I don't need to because all I'm looking for is these intersection points. So I go second calc, once again intersect 5. My blinker is closer to this side, so I'll find that. Just hit enter 3 times. 1, 2, 3. And I get 1.14. And that problem's done for that side. Let's go back to the calculator, find the other intersection. Second calculate. Move that over to the other side. Find the blinker. There it is. Hit enter 3 times. 1, 2, 3. And I get negative 6.14. And those are my 2 zeros or roots or x-intercepts, whatever you want to call them. Let's do one more word problem. A little bit of reading going on. We've got a dam. It's got a 726 foot tall high building above the ground. We know that we drop something from a height of 6 feet above the top of the dam, so really 6 feet above this. Alright, since the dam is 726 feet tall, we're adding 6 feet to that. We want to know how long it takes for the marble to reach the ground, assuming that this is the equation of the fall. So our initial height above the water is 726.4 plus that 6 feet above the ground, which is 732.4. We're going to plug that into h of O. So h of t is equal to negative 16 t squared plus 732.4. We also know that we want the ground height to be 0 after the marble falls. So I go negative 16 t squared plus 732.4. And we're going to pop that into our calculator once again. Go y equals negative 16 x squared plus 732.4. Again, if I want to see this, I'm going to have to look up pretty high because at 0 we're at 732. You wouldn't think it's going to take too long for the thing to drop, so let's keep that at 10 seconds. But let's go up to 800 just so we see the height and the fall. Go ahead and graph it. And there we go, dropped it down, and there it falls. We want to know where it hits the ground, so I go second calculate. Once again, the intersect, and I move it over to the right a little bit, and I hit enter 3 times. And it's going to take about 6.77 seconds. 6.77 seconds to hit the ground. That's really all we've got today. Figure out how to use your calculator to find these intersection points. The biggest thing is trying to work on getting your window accurate so that you can see everything. So make sure you do your lesson summary and do your Connect Ed problems. See you tomorrow.